we've talked about trig functions really just of acute angles and on the unit circle and stuff like that. But now we're going to talk about trig functions in a circle where the radius could be anything you want it to be, okay? Like 5 or 10 or 26 or whatever you want it to be. So I'm going to try to draw a circle. If I can find a circle, here's a circle. Let's make a circle here. Okay, so here's a circle, and I kind of do this. Oops, good enough. Good enough. Like that. What's so funny? All right, and so so if this is the radius, okay, which no matter which way I go, the radius will go somewhere in this circle. I can move this radius here. I can move this radius here. I can move it over here. Okay. Well, let's say that the radius doesn't change. So r is always a positive number because a radius is a radius is a radius. Okay, and it has a length. It can't have a negative radius. But say I have this point over here, okay, and I have some point on my circle, which I'm going to call x, comma, y, right? So these, for any angle, because before we only had when this has a radius of 1, but this could be any radius, and this angle could be anything. So the sine of this angle, some angle from here to here, you always go counterclockwise from the x-axis. Sine of theta, which I'm going to call this theta now, is going to be equal to this side here is x, and this side here is y, still. Right? So the sine of theta is going to be opposite over hypotenuse, y over r. And the cosine of theta is going to be what?
R over 1.
That's the 1 over sine. It would be x over r. And the tangent of theta would be equal to, what would the tangent theta be equal to? Y over x. Very good. Okay. Now to find, so don't get confused with the cofunctions and the reciprocal functions.
How is the tan y over x?
Opposite over adjacent. Okay. Opposite over adjacent.
Yes.
Okay. And the r is always positive, but in this case, and r can't be 0, but x cannot be equal to 0 because if x is equal to 0, then I get undefined. You understand that? You can't have the bottom be 0. Then I flip them over, and I get the cosecant of theta is equal to r over y, and I get that the secant of theta is equal to the reciprocal of this, r over x, and I get the cotangent of theta is equal to x over y. And again, in this case, y cannot be equal to 0. And in this case, x cannot be equal to 0 because otherwise you'll get undefined. And in this case, y cannot be equal to 0. So you will see there are some points when we graph these trig functions, you will see that cosecant and secant and cotangent and tangent all have places where they are undefined, okay? When x and y are 0, right? But sine and cosine is a continuous function. It never has places where it's undefined. Okay? So given a point on a unit circle, so say this point over here, instead of calling it xy, I call this the point -4, comma, -5. And I say find the trigs, the six trig functions. Could you do that?
Are we assuming that the center is 0, 0?
Are we? Whoops, that's wrong. Yeah, you're assuming that the center will always be at 0, 0. And I messed up because that shouldn't be a positive 5. It should be -4, comma, -5. Okay? So they'll say find the 6 trig functions for this circle in which the point that you're talking about is -4, -5. Okay? So all you have to do is plug into these formulas, except I need to know this side. How do I find that side? How do I find it?
Pythagorean.
Pythagorean theorem. So in this one, it doesn't come out really neat. If this were 3 and 4, it would, but if this point is -4, -5, that means that this hypotenuse would have to be 16 plus 25, is that right? 16 plus 25. How much is 16 plus 25? 41? Say 41. 41. Very good. I knew you guys did. Okay, so r is equal to the square root of 41. And so then I just plug in y, so sine would be -5, so sine of theta in this case would be -5 over square root of 41, okay? And they really probably, if you left that on a test, I probably wouldn't mark it wrong, but you should really rationalize your denominator by multiplying by root of 41 over root of 41, okay? So that would give you -5 root of 41 over 41. And that's a lot of work for each problem. So cosine of theta would be what? Who can tell me what cosine of theta would be? Cosine of theta?
-4 over.
-4 over root, right? -4 over root of 41, and so on and so forth. So then get the secant, you would flip that. To get the cosecant, you would flip that. To find the tangent of theta, who can tell me the tangent of theta? Negative, good. -5 over -4, which is just what? 5/4. Okay, so tangent is going to be positive there. And the cotangent, what's cotangent going to be there? 4/5. Okay, and so forth. So they'll say find the sine, cosine, tangent, all 6 trig functions with that angle who's got these coordinates. All right, as the endpoint of the terminal side. They call this the terminal side, meaning where it stops. The other thing I talked about the other day, all students, this becomes important. Take calculus, okay? And this stands for all of your trig functions are positive. It kind of tells, it doesn't tell you where the functions are negative, it tells you where everything's positive. So all the trig functions are positive here. Sine and its cofunction, and not its cofunction, its reciprocal function, which is cosecant, are positive, okay? All are positive. You might want to make a note of this because it's an easy way to remember. Here, the only ones that are positive are tangent and what else? Cotangent are positive here, right? Because that's, both of those are negative, and a negative divided by a negative makes it positive. And over here, cosine, just cosine and its reciprocal function, which are secant, are positive, and everything else is negative because x is positive and the radius is always positive. So that's the way you look at that.
Wait, how is this different from the right triangles?
It's different in that you would have like negatives and positives, okay? Instead of just with right triangles, you only can have positive signs and cosines. You know what I mean? With acute triangles, right? You only have positive things. But here you could have negative signs and cosines and stuff like that. So, okay. What if they give you one like this? There's more. There's lots more. I'm sorry, but I just work here and I got to teach you, okay? Cosine of theta equals negative, oh, whoops, sorry, wrong problem. I gave you the answer. I said sine of theta equals negative 2/3. You'll see some problems that look like this. And tangent of theta is greater than 0. And it'll say find cosine of theta and cotangent of theta. And you say, I have no clue whatsoever. Do you have any clue whatsoever how to do that? Who can tell me how to do that? Can anyone tell me how to do that? No? Good. So maybe I'll teach you something. So So first thing, you don't have to draw in the circle every time because this doesn't actually have to be a circle. It's an x and y axis, right? So what you know is that the sine, first you have to figure out which quadrant you're in. Which quadrant am I in if sine is negative and tangent is positive? Look at what I just told you. Very good. In the third quadrant. Do you understand why that is?
One and a second.
What? Sine is positive in the second quadrant.
Oh,
That's
okay.
y is positive in the second quadrant. So you would come over here to the third quadrant and you would draw a picture of some kind of angle over here. I don't know why all my lines are dotted. So what you're talking about is some theta that ends up being over here. Because sine of that angle is negative and the tangent is positive. Here the sine is negative and tangent is negative divided by negative, so it's positive. So first you have to figure out which quadrant you're in, and then just use these numbers. Sine is 2 over 3. You don't have to worry about the sign because you're just doing,
Wait.
yep, sine is opposite over hypotenuse. Negative 2 over positive 3. So this is not a unit circle. The radius is now 1, right? It's negative 2 over 3. And then you use the Pythagorean theorem to find this side. So let's do that. You're going to go, you don't even have to put the negative 2 because when you square it, it ends up being, so you're going to go 2 squared.
Wait, Mr. Luder.
What?
How do you know that like left side is not just negative 2/3?
It could be. You could call this side negative 2/3 and this 1, you'll still get exactly the same answer. Okay? But I don't like to square fractions. You understand what Henry just asked? He said you could call this negative 2/3 and this 1, and that would work as well. But I don't like, but then I have to do the Pythagorean theorem with a bunch of fractions, and I don't want to do the Pythagorean theorem with a bunch of fractions, okay? And so now I do the Pythagorean theorem, negative 2, 3. So you go 2 squared, we'll call this b over here, right? 2 squared plus b squared equals 3 squared. So you get 4 minus 9 is 5. So b squared, oops, my Moby died. B squared equals 9. B equals, and you don't have to worry about that.
Would it be 5?
5 it would be. I have that in my notes, but I just wasn't thinking. Okay? So b equals the square root of 5. And you don't have to worry about that being negative or positive because that's a, what is it? Is it negative or positive? Sorry, you do have to worry about it. Is x negative or positive over here? Negative. So b is actually negative the square root of 5. So what I would do is call this side negative square root of 5. All right? That way you can find cosine and theta. What would cosine of this angle be? Look at the picture. What's the cosine and theta? X over hypotenuse. What is it? Yes, negative square root of 5 over something. I write thinking something and something else comes out from there. But what's the cotangent? Cotangent. Cotangent of theta. Are you guys alive in here? This adjacent over opposite, right? So and those are both negative, so that becomes positive root of 5 over positive 2. All that? No? No? Okay. So those are kind of fun little problems. Okay, you'll see about 30 of in your homework tonight. Okay?
30?
Something like
You
that.
already gave us a homework.
Mr. Leader, I say we just take the weekend off.
Okay.
Well,
Then-
no, let's go down. Can't work at time for math.
Okay. Then we have these things called quadrantal angles, and I'm just going to kind of talk about these. We kind of already talked about these somewhat. But say you want to know the sine of pi over 2. Who can tell me what the sine of pi over 2 is? Look at this angle right here.
0. 1.
You can label this point anything you want to, but I know that x has to be 0 and y has to be something else, right? So, and I could call it 1, I could call it 5, I could call it 2. It doesn't matter.
Wait, how'd you get to that again?
Math. We'll say
What?
Oh,
Say 1.
It's undefined.
How did I get this?
Yeah, how'd you get 0 and 1?
I just,
Sine of pi over 2.
What? No, that's not the answer yet.
Oh.
I just put a point on my axis. Okay,
Oh,
so
okay.
say you want to know, because this is pi over 2 radians, right? Okay, and this is pi radians. And this is 3 pi over 2 radians. And this is 0, but it's also the same as 2 pi radians, right? So if I put there sine of pi over 2 is, sine of pi over 2 is 1 over 0, which is what? What's 1 over 0? Wait a minute. I messed up. No, I didn't really mess up. It's 1 over, if this is a 0.01, that means the radius of my circle, which I would have drawn, is how long? 1. So that would have been 1 over 1, which is just 1. Okay? What would be the cosine of pi over 2? Cosine of pi over 2. 0 over what?
0.
0 over 1, not 0 over 0. 0 over 1, which is equal to 0. The tangent of pi over 2. What's true about tangent pi over 2? What's that equal to? 1 over what? 1 over 0. What's 1 over 0?
Not.
Undefined. Okay? That would be undefined. What's the cotangent of pi over 2? 0 over 1.
Where's the triangle?
0 over. There is no triangle because like the triangle disappeared because it's straight up and down triangle. You see, if theta, what? Because if this were the, okay, let me show you. Okay, I gotta draw a circle. Circle. So if I go, here's my circle, right? Okay, and if I were going to draw in an angle right over here, right? As I drag this over to here, my triangle disappears. You follow that? But my radius is still 1. See that? Here's my triangle now, right? As I get closer and closer and closer, this radius and this side become the same thing. So it's kind of.
Oh, like where's the triangle that we're working on?
There is no triangle, it's just straight up and down. It's just straight up and down. Okay, all right, think about that, Savannah. All right, then we have something called reference angles. Reference angles. Next thing, reference. Do you like this color? How about blue? What color does that look like to you? Oh, on my screen I showed you. This is a really nice blue. It's like a teal. Reference angle, okay? And what a reference angle is, if you have a circle, the reference angle is the angle that let's get rid of the dotted lines. Let's make solid lines. The reference angle is the angle that your radius makes with the x and the y-axis, okay? For instance, well, let's draw in 4 different angles right here. So we'll change this to orange. So over here, okay, here, here, and here, right? This angle right here is the reference angle, okay? So if I'm in the first quadrant, if I'm talking about the reference angle, it's this angle right here, okay? If I'm in this quadrant, my reference angle is right here. If I'm in the third quadrant, my reference angle is right here. And if I'm over here, then my reference angle is right there. So how do I use reference angles? Say they want to know, they say find the reference angle. Find the reference angle for 313 degrees, okay? How would I do that? Who can tell me what the reference angle would be? What did you say?
47.
Who? What?
That's it.
What did you say, Catherine? So, how far is it from here to here?
360.
360. Subtract Good, so I'm talking about this, if I'm doing that, I'm talking about this angle from here to here, right? So the reference angle is gonna be 360 minus that 313, right? So it would be 360 minus 313, which gives you out, I think, 47 degrees. Why would you ever want to know that? Because maybe,
But wouldn't it be negative 47 degrees because it's an angle of compression?
if you wanted to find the sine of the angle, you would talk about a negative, but the reference angle is always a positive angle. Okay, so the reference angle is a positive angle. What if I wanted to know?
How do you know which one's the reference?
It's the reference angle that the radius makes, the acute angle, it's an acute angle, that the radius makes with the x-axis, So that's kind of a definition of the reference angle. And use that, I'll show you how to use that in a minute. Say I did negative 143 degrees. What would be the reference angle to negative 143 degrees? You want to find a positive angle. Then which way am I going to go? Which quadrant is negative 143 in? Second quadrant's over here, right? So if I go 180 this way and subtract 143, right? I would get this angle right there. So we go 180 minus 143, and the reference angle is, what's that, 37 degrees? 37 degrees, and that's the reference angle.
Isn't that the third quadrant though?
Is it what?
Isn't that the third quadrant?
Yeah, that's what I said.
Oh, sorry, so it's
That's 3. You messed up there. That's 3, that's 1, that's 2. Okay, 1, 2, 3, 4th quadrant. That's a pretty picture, isn't it? Looks kind of cool. What if they said, find the reference angle for 2.3 radians? What if they said find the reference angle for 2.3 radians? Which quadrant would that be in? Which quadrant would 2.3 radians? Where is 3.14 radians? Which quadrant? I don't think so.
second
So this is pi radians to here. That's about 3.14 radians, right? So where do you think 2.3 radians would be? It would be in the second quadrant, right? So you're talking about this reference angle over here. This would be 3.14 divided by 2, which is 1.6 something or something like that. So 2.3 radians is going to put you in the second quadrant. So to find out how many radians this angle is, I would take pi radians, because it's pi radians to here, minus 2.3 radians. And if I do that, I get 3.14 minus 2.3. I don't know what that is. What is that, 1 point?
Convert to degrees.
Because that's more work, because you got to start thinking in a foreign language. Okay? Okay? So it comes out to be about 0.84 radians. Okay? If you did that. So this is why you learn this stuff, because they'll say use the reference angle to find the sine of 7 pi over 4. Okay? So again, what you want to do, it's always, I think the best way to do all these problems is to draw a picture. Okay? Sine of 7 pi over 4. Which quadrant am I in at 7 pi over 4? Think in radians. Where is 8 pi over 4? Where's 8 pi over 4?
It's 2 pi. So
It's 2 pi, so 8 pi over 4 would be here. So where would 7 pi over 4 be?
fourth pi.
Fourth quadrant, right? So it'd be down here, and it'd be like this, right? And so what would this angle, you don't even have to really do it, what would this angle be in terms of radians? How many pi's over 4 would that be?
1.
1 pi over 4. So the reference angle, so that's the pi over 4, okay? And so if I want to find the sine of 7 pi over 4, I would go sine of, one way to do it is to go the sine of pi over 4, which you should know from your unit circle. What's the sine of pi over 4? Square root of 2 over 2. Very good. Root of 2 over 2. But in this quadrant, is sine negative or positive? Sine is negative, right? So the sine of 7 pi over 4 is not positive root of 2 over 2, but it's negative root of 2 over 2. Because you have to, so the reference angle doesn't take into account which quadrant you're in, okay? But then you have to think about which quadrant is this bigger angle in. And it's just kind of a way to think about things, okay? So that's that. Tangent, should we do another one? I want to move on. Okay, so using trig identities. So, okay, this isn't too bad. So last example. It's the last example. Let theta be an angle in quadrant 3. In quadrant 3, they do that with Roman numerals, such that sine of theta, sine of theta equals negative 3/4. Okay? Use a trig identity. So this is using trig identities and what you just learned, okay, to find cosine theta. Okay? So what trig identity could I use? Can anyone tell me? With sine and cosine, what trig identity did we talk about earlier? Sine squared plus cosine squared, okay? So I know that, so that's what I'm going to do. I'm going to use sine squared theta plus cosine squared theta equals what? 1. So now I'm going to, sine of theta is 3/4. So I can go negative 3/4 quantity squared plus cosine squared of theta equals 1. What's 3/4 squared? 9 over 16, right? You have to square both things. Plus cosine squared theta equals 1. So that gives me 1 minus 9 over 16 equals cos squared theta. And what's this equal to? Anyone? How many 16ths?
16
7. So cosine squared theta equals 7/16. So cosine of theta equals plus or minus, when you square root something, the square root of 7 over 16, which is equal to plus or minus the square root of 7 over 4. And then you have to decide, is it plus or is it minus? Which quadrant am I in? Third quadrant. So is it plus or is it minus? Negative root of 7 over 4 because cosine is negative in the third quadrant. Follow that? Okay, so that's a lot of work, yeah.
Wait, why cosine, not sine?
Because that's what the question asks, to find cosine of theta.
Oh,
Right?
okay.
Okay, so use that. All right, your homework, it seems like a whole ton, it's 27 problems or something like that, but they're short. It says give the reference angle to this. You only have to do this kind of stuff a couple times. So if you look on my website, I'll bring you to my website and show you what that assignment is. And don't moan and groan, just do it. It'll go fast once you start doing it. Am I giving I walked around and then checked it already, didn't I? Right, okay. So, There you go. Advanced.
No, dude.
Harsh. I'm harsh. Whoops. Okay. You got assignments, you can just go to my website. You can look here and you can get it. It's on my website. Right. No, it's not. It's not right there.
I did it.
It's the one below it. Sorry. Okay. Right here. Page 289. So this means 12 to 34 every third, 36 to 108, that's every other even. So that I counted those at 16 problems in there, okay? And it's just like find the reference angle, if cosine is this, what's the sine and stuff like that. 12 to 34, 1 through 10, and then a couple of little thinking problems there. So that's it.
And I got it right.
And I talked for 30 minutes.